Hello dear students, welcome to the lecture 9 of Security of Information Systems. So today's topic is,
Identity management and access control.
okay, so the outline of today's course is like here.
Identity and access management concepts. Identity management models. Access control models, security models.
Okay, so IAM, which is Identity Access Management. So there is configuration phase. At the configuration phase, there is registration and provisioning and then authorization. So this part, the green part is identity management, and the yellow part is access management. And at the configuration phase, there is authorization in access management and registration and provisioning in identity management. At the operation side, in identity management phase, there is self-identification, authentication, and at the operation phase in access management stage or phase, there is access control. Okay. Okay, so I will check something. Okay, so definition of identity and access management is like here.
Identity and access management (IAM) is the security discipline that enables the right individuals to access the right resources at the right times for the right reasons. IAM addresses the mission-critical need to ensure appropriate access to resources across increasingly heterogeneous technology environments and to meet increasingly rigorous compliance requirements.
Okay, so there is a link. Let's check it out. Okay, it is the source of the definition. Let's continue. The concept of identity. Okay, let's try to understand what is the concept. So there are organizations like schools, persons like us, systems, I don't know, maybe like broadcasters. These are the entities that have identity. Maybe our smart devices can be also considered as systems, such as our robot vacuum cleaners and such. So entities have identities, of course. You see there is a gray identity and some black and white boxed identity, and each one have different attributes such as names, identifiers, characteristics. Okay, let's continue.
Concepts related to identity.
So entity,
A person, organization, agent, system, session, process, etc.
so entity is basically any of these. So identity can be as,
A set of names, attributes of entity in a specific domain. An entity may have identities in multiple domains. An entity may have multiple identities in one domain.
okay, so there is digital identity, which is,
Digital representation of names, attributes in a way that is suitable for processing by computers.
okay, and
Names and attributes of entity can be unique or ambiguous within a domain. Transient or permanent, self-defined or defined by authority, interpretation by humans and or computers, etc.
okay, let's continue. Identity,
Etymology, original meaning of words. Identity equals same one as last time. First time authentication is not meaningful because there is no previous time. Because the identity first must be created, registered. Authentication requires a first-time registration of identity in the form of a name within a domain.
This is true. Whenever you register, whenever you want to use a website such as Facebook, Twitter, Instagram, or you want to make a purchase from an e-commerce website, you register an account there. So you create your identity on that domain, and then that identity will always point to you. That is why we use IDs in our program software, and that ID never changes throughout the lifetime of that entity, because it be a unique thing to identify that entity. I think you get the idea.
Registration can take two forms. Pre-authentication, from previous identity, e.g. passport. Creation of new identity, e.g. newborn baby.
Okay, so this is a examples from real life. When you get a password, you use your identity to get a password. Or, however, when you are a newborn, you get a new identity first. Okay.
Identity domains. An identity domain has a namespace of unique names.
Okay, and
Same user has separate identities in different domains.
okay. So Silo ID domain in service A, federated ID domain, service B, service C, service D. So in Silo ID domain at service A, the user gets ID 1, and in federated ID domain, which has service B, C, D, the user gets ID 2. This is a very common way of practice. Different domains would assign different IDs to the same entity.
Identity domain structures. Silo domain with single authority, e.g. user IDs in company network. Distributed hierarchic domain, e.g. DNS, domain name system. Federated identity domains. Identity domain can be used by many different service providers. Requires alignment of identity policy between domains.
Okay. Maybe we can find some more information related to this. Okay, so SVID user. Okay, so let's read it. Silo model is like this. Explain it.
The main identity management system deployed currently in the world of the Internet is known as the silo model, as shown in Fig. 71.6. Indeed, the IDP and SP are mixed up and they share the same space. The identity management environment is put in place and operated by a single entity for a fixed users community. Users of different services must have different accounts and therefore re-enter the same information about their identity, which increases the difficulty of management. Moreover, the users are overloaded by identity and password to memorize, which produces a significant barrier to usage.
Okay, for example, this is like you own several domains on several name server providers such as on GoDaddy and Namecheap. For each domain name provider, you register a different account. However, what you do is essentially having domains from the same pool actually, but since you use different accounts in different services, it is hard to manage. So this is called as silo model. Let's read the definition here as well.
Identity silo is a standalone identity store that is specifically designed to support a particular software application. Identity silos pose an information assurance and administrative problem for organizations because the access control rights and privileges controlled by an identity silo can't be traced back to authoritative sources or to human resource (HR) directives to add or remove employees.
Okay, so identity silo is a single source of identity management for each service. You define for each service you create an account. Therefore, it is hard to manage them centrally. However, in federated ID domain, you use multiple services from single management. Okay, so now we get the idea.
Taxonomy of identity management architectures.
Okay, identity management is split into two major branches, which is silo identity management and federated identity management. The federated identity management is split into three branches: centralized federation, distributed federation, and hybrid centralized distributed federation. Okay, so the silo identity management system is illustrated like this. There is silo IDP, SP, IDP. So SP is the user, for example, our school. IDP is identity provider. Okay, so SP can be entity. Okay, and there's identity domain, which is the green area. There is user identifier for silo domain here, authentication token, service login, service provision. Okay, so you see, same entity, same person gets three different identifiers for each identity domain here. Okay, he can't use a single account to manage multiple services, use multiple services. On each service, you see service A, service B, service C. He has to create a different account. He has to create a different password for each account, and he has to log in each of them. So this is silo identity management model. Okay, this is the usual one we are used to use, such as on e-commerce websites, such as on Facebook, Twitter, Instagram, etc. We create an account on each system, and then we use that particular account to manage that system. Okay, so silo ID domains. Oh, okay, SP is a service provider, IDP is identity provider. I see.
SP, service provider, equals IDP, identity provider.
So SP controls namespace and provides access credentials. Okay, so the SP is creating your user ID and providing you the access credentials. And in silo ID domains, SP and IDP is same. You see, they are same. They are equal. Unique identifier assigned to each entity. Advantages: simple to deploy, low initial costs for service providers. Potentially good privacy. Disadvantages.
Identity overload for users, poor usability, no business integration.
Yes, we have to compose a different account for every service we use, and that is some overload for us. That is true. Therefore, these are the disadvantages of silo model. Okay.
Low acceptance of new services with separate ID and credentials. Users must provide same information to many service providers. For service providers, barrier to service bundling and data collection.
Okay, so these are the disadvantages of silo ID model, and there is the identity federation model.
Identity federation. A set of agreements, standards and technologies that enable a group of SPs to recognize and trust user identities and credentials from different IDPs, CRPs and SPs.
Okay, we know the IDP and SP, so let's see the CRP. Okay, so there are four main types of identity federation, which is, first one is centralized federation.
Centralized namespace and management of credentials by single IDP, CRP.
Okay, identity provider and credentials. Okay, credentials provider. So CRP is credentials provider. Okay, so the second type.
Distributed identity with centralized authentication. Distributed namespaces managed by multiple IDPs. Centralized credentials authentication by single CRP.
So the third the third type of the federation style identity management is
centralized identity with distributed authentication. Centralized namespace managed by single IDP. Distributed management of credentials and authentication by multiple CRPs.
And finally,
distributed federation. Distributed namespaces and management of credentials by multiple IDPs and CRPs.
Actually, distributed federation looks like silo ID style. Let's see. So identity federation types, centralized identity. Google Plus. Why Google Plus can be given as centralized identity? Because they are all linked to Google. So Google uses the same identity management for all services it has. You just use your email, Gmail in this case, to log in every service of Google. Use every service of Google. Therefore, Google is a very good example of centralized identity. So there is distributed identity, which given as Facebook and Twitter. However, they have centralized authentication. What does this means that Twitter gives you different IDs for different services. However, they use the same authentication service. What can be given as an example for this? For example, Twitter has some ads platform or a developer platform. They give you different IDs. For example, developer give you different developer ID. However, they use the same centralized authentication, same for Facebook. So there is distributed authentication and centralized identity example, which is given as ID Portal and Altin. I don't know these services. And there is distributed authentication and distributed identity. The Eudoram. Okay, so Eudoram looks like a mobile service provider. Has the ID. I don't know. Let's check them. FIDE. Okay, I don't know any of this. Anyway, so you get the idea. Federation model types.
Aadhaar, India, and Google Plus are centralized Bekau.
Because
Hey, control and manage the domain's namespace of identities. They always verify the authentication credentials in their federations.
okay.
Facebook and Twitter have distributed identities and centralized credentials because they do not manage identities which are ordinary email addresses, they always verify the authentication credentials in their federations.
Okay, so this is a better explanation than mine. And let's see.
The ID portal Norway has centralized ID and distributed authentication because
Oh, I see.
identities are national ID numbers, managed by the government. Multiple private credentials providers verify credentials for authentication.
Okay.
OpenID and Eduroam are distributed because multiple ID providers control and manage namespaces for identities. The same ID providers also verify the credentials for authentication.
OpenID. So let's see some information related to OpenID.
OpenID allows you to use an existing account to sign in to multiple websites without needing to create new passwords. You may choose to associate information with your OpenID that can be shared with the websites you visit, such as a name or email address. With OpenID, you control how much of that information is shared with the websites you visit. With OpenID, your password is only given to your identity provider, and that provider then confirms your identity to the websites you visit. Other than your provider, no website ever sees your password, so you don't need to worry about an unscrupulous or insecure website compromising your identity. OpenID is rapidly gaining adoption on the web, with over 1 billion OpenID-enabled user accounts and over 50,000 websites accepting OpenID for logins. Several large organizations either issue or accept OpenIDs, including Google, Facebook, Yahoo, Microsoft, AOL, MySpace, Sears, Universal Music Group, France Telecom, Novell, Sun, Telecom Italia, and many more.
Okay, so this makes sense.
Who owns or controls OpenID? OpenID was created in the summer of 2005 by an open-source community trying to solve a problem that was not easily solved by other existing identity technologies. As such, OpenID is decentralized and not owned by anyone, nor should it be. Today, anyone can choose to use an OpenID or become an OpenID provider for free without having to register or be approved by any organization.
Okay, so now we get the idea of the 4 different models of federation types.
Identity federation roles.
Okay, there is users as federation role.
Needs identities and credentials to access multiple SPs.
So entities.
Service provider SP. Needs to know identity of users, and needs assurance of user authenticity.
For example, Facebook, Twitter, Google are service providers.
Identity provider IDP. Controls namespace of identities. Issues registers identities for users.
Identity provider can be your government or Google, Facebook. They also provide identity, and there is the
Credentials provider, CRP. Issues registers credentials for users. Performs authentication of users.
same Google, Facebook, Twitter. They also provide credentials. Okay, so by the way, Facebook and Twitter are not identity providers because you register them with your email. However, they also compose an identity for you actually in their system, but they define you with your email address. However, internally they also provide an identity to you, but we count them as service provider and credentials provider. Gmail is both service provider, identity provider, and credentials provider, and such. Okay.
Federation protocols. Authentication by one IDP, CRP, SP is communicated as a security assertions cryptographic token to other SPs that trust and accept the assertion of authenticity.
Okay.
Usually based on SAML protocol. Security assertions markup language.
So what is this?
Security Assertion Markup Language (SAML), pronounced SAML1, is an open standard for exchanging authentication and authorization data between parties, in particular, between an identity provider and a service provider. SAML is an XML-based markup language for security assertions statements that service providers use to make access control decisions. SAML is also a set of XML-based protocol messages, a set of protocol message bindings, a set of profiles utilizing all of the above. An important use case that SAML addresses is web browser single sign-on (SSO). Single sign-on is relatively easy to accomplish within a security domain using cookies, for example, but extending SSO across security domains is more difficult and resulted in the proliferation of non-interoperable proprietary technologies. The SAML web browser SSO profile was specified and standardized to promote interoperability, too.
Okay. Involves multiple entities.
User, IDP, CRP, SP, and sometimes broker entity.
Okay, so service providers such as our university, user is us, identity credentials provider is someone else, some other service, and there is the broker which separates, which actually links us through service provider and identity credentials provider. Okay, so let's continue.
Advantage, disadvantage of federation.
Okay, so advantages are improved usability because you use single account to use multiple services, allows SPs to bundle services and collect user info, of course, because you provide multiple services with single account, therefore it is much easier to collect user information, and then you can know all these information belongs to the same user entity. And
Strengthen privacy through pseudonym identities.
okay, and what are the disadvantages? High technical and legal complexity. It is harder to achieve federation model. This is of course true because it requires more complex programming and technologies. High trust requirements between parties because you are letting some other party to authenticate the login. and you have to trust that, of course, because with that other parties trust, you are letting a user to use your services. Each federation partner can potentially compromise security. This is true. Privacy issues. Massive data collection is a threat to data privacy. By the way, this is a threat for users themselves, not the service providers or such. And limited scalability. Limited by political and economical constraints, it is harder to scale it. An identity federation can become a new form of cyber. Yes, this is also true. And centralized federation is illustrated like here. So in here you see they use the same user identifier here, all linked, and different service providers, and they use same security assertion you see here, issued by the identity provider. So the user uses only single account and single password to use all the services. Okay. Example, Facebook Connect, you see. Okay, let's see.
SAML Protocol Profile, Browser Post Security Token via Front Channel. Federation Circle of Trust.
Okay, one more. Okay. There is identity provider and service provider. So how they communicate? So the user uses browser to request for token from identity provider. Identity provider sends the token with encryption to the browser. Then browser sends token to the service provider, and service provider verifies token with the Federation Circle of Trust. You see they are linked with the broker. Then service provider, once verifies the token is valid, they start providing services. The token based authentication is pretty common in lots of modern services. So this was the browser post security token via front channel. There is also a browser artifact security token via back channel. And here the user uses browser to request for token. Then identity provider this time provides artifact. So what is artifact? Authentication. Okay. Okay, anyway, it is called as artifact, I guess. Then artifact is sent to the service provider. Then the service provider sends back artifact to the identity provider. Then identity provider provides a token to the service provider. And once it is verified, the service provider starts providing service. And this is the back channel. You see the token is sent back and forth by the back channel. Okay. And there's OpenID Connect protocol. Let's see it, how it is done. Okay, and Federation Agreement. So service and OpenID agrees initially. Then client here requests resource from the service provider. Then the service provider sends list of identity providers. Then user selects one of the identity providers. Okay, this can be like, for example, you want to log in, let's say your school website, and your school website gives you option to use your email or OpenID. This is what it means. You pick your authentication identity provider to log in and you start using that service, then the service provider redirect client to get the token from identity provider. You see there are always redirects when you are using, I think you know that such services, and from that redirection page you are supposed to log in, and then client is redirected to authentication OpenID, I mean identity provider, and you see there is authentication request, and then the identity providers provides the login page where you enter your credentials such as your password and username, and then where is the seventh step? Okay, you see the client provides credentials such as your password and username, as I said. Then it is sent back to the identity provider, and you see post credentials. When you hit the login button, you send your credentials usually over HTTPS. Actually, it has to be over HTTPS for security. If not, it is not secure. Then identity provider provides you token and redirect you to service provider, and with token here you see at the step 10 you forward token back to the service provider. The service provider starts providing you the service. Okay.
OpenID Connect characteristics. Based on OpenID and OAuth 2.0 specifications.
OAuth 2 is extremely popular. I don't know if there is the newer version. For example, you see using OAuth 2.0 to access Google API, Microsoft Identity Platform, and OAuth 2. And there are a lot of OAuth 2 authentication. For example, let's write Twitter. Okay, it comes, and Facebook. Okay, it comes. You see authentication of the Twitter with OAuth 2. Let's read it.
OAuth 2.0 Bearer Token. OAuth 2.0 Bearer Token authenticates requests on behalf of your developer app. As this method is specific to the app, it does not involve any users. This method is typically for developers that need read-only access to public information. This authentication method requires for you to pass a bearer token with your request, which you can generate within the Keys and Tokens section of your developer apps. Here is an example of what a request looks like with a fake bearer token plugged in.
Okay, so you see these are used in the current authentication system. These are not just let's say not just theoretical applications. These are being used in practice.
SPs establish federation agreements with IDPs. Beware of abuse of term authorization. The OpenID Connect standard uses authorization in the meaning of authentication and access control. OpenID Connect used in the Norwegian Health ID. IAM for the Norwegian health sector. Health professionals register OpenIDs that are independent of their national person numbers. Mapping between OpenIDs and person number exists but is protected. Google, Facebook, and Twitter federations.
Okay, so how they use authentication? The user, by using browser, requests service from, let's say, Google. Then it goes to the service provider. Oh, by the way, so this is something else. This is how Google, Facebook, and Twitter are being authentication service. Okay, not the identity provider, or they are being identity provider as well. Yes, authentication service. Then the service provider asks Google, Facebook, or Twitter, and then Google, Facebook, Twitter asks you to log in by providing your ID and credentials. Then they are forwarded back to these federations. Then they provide token or assert authenticated user, and then you can start using services. I am sure you have already encountered with Google login. It is a good example of this, or Facebook login. For example, nowadays in mobile games, you can log in with Facebook, or the usual method is we log in with Google Play services. That is exactly like this. Okay. And the network access. Okay, let's check this. So there is visitor, which is being us, and we use the Adoram. Okay, I had guessed this was related to network, and I was true. And then Adoram checks which institution you are from. Then it sent back something. Okay, let's read this.
Eduroam has formal agreements with the public and private locations around Europe for network access. Home institutions, universities, are responsible for keeping user data and credentials correct and up to date. Networks provide internet access.
Okay, I see. So this is distributed both in authentication and yes, identity, because the authentication and identity is given by the universities. Adoram is just the middle service provider here.
Felles elektronisk identitet.
The FIDE is also another distributed identity and distributed authentication. Let's read about that as well.
FEIDE is a distributed federation with centralized broker for the Norwegian national education sector. Users register username and password with own home organization. Users authenticate to web services via FEIDE's centralized login service. The service provider receives user attributes from the user's home institution. The service providers never sees the user's password, credential. It only receives user attributes that it need to know in order to provide the service.
Okay, and continue it.
FEIDE has formal agreements with the universities and schools before they are connected. Home institutions, universities and schools are responsible for keeping user data correct and up to date. Service providers decide themselves what services their own users and other users should be able to access via FEIDE's central log-in service.
Okay, I think this is a good example. So the scenario is illustrated like this. The user request service from service provider return, okay, it is shown here. Let's read it.
1. User requests access to service. 2. Service provider sends authentication request to FEIDE and displays FEIDE login form to user. 3. User enters name and password in FEIDE login form, which are sent for validation to home institution of user. 4. Home institution confirms authentic user and provides user attributes to FEIDE, which forwards these to SP5. Service provider analyzes user attributes and provides service according to policy.
Okay, and there is another example scenario of ID portal MinID. This is the ID portal Norway broker, credentials providers, bank ID, Confise, Bypass, MinID. These are the services, and they are all provided by government service providers. In Turkey, we also have e-government. As you know, we use it. E-government is used to authenticate many services such as when we want to log in our let's say UYAP, or we want to log into Gmail and such, or Enabus. I am sure you know that you know those. We use the government login, e-devlet, e-government.
1. User requests service access. 2. Service provider sends authentication request to ID portal and displays ID portal login form to user. 3. User selects credentials provider, enters name and password in login form, which are sent for validation to credentials provider of user. 4. Credentials provider confirms authentic user and provides user attributes to ID portal, which forwards these to SP5. Service provider analyzes user attributes and provides service according to policy.
Okay.
Noru, eGov, distributed Fed, with broker.
So this is Norway e-government system distributed with federation with broker. Authentication methods are grouped like here, and there is identity portal. Okay, you get the idea how it works. I will take a pause here. Okay, so introduction to logical access control.
Physical access control, not the theme today.
Okay, yes.
Logical access control, this lecture.
Okay.
Basic concepts. Access control security models, how to define which subjects can access which objects with which access modes. Three classical approaches: discretionary access control (DAC), mandatory access control (MAC), role-based access control (RBAC). Advanced approach for distributed environments, attribute-based access control (ABAC), generalization of DAC, MAC and RBAC.
Okay.
Access modes. Modes of access, authorization specify the access permissions of subjects, users, when accessing objects, resources. If you are authorized to access a resource, what are you allowed to do to the resource? Example, possible access permissions include, read, observe, write, observe and alter, execute, neither observe nor alter, append, alter. DAC, MAC according to the Orange Book, TCSEC. TCSEC, 1985, specifies two AC security models. Discretionary AC, DAC AC policy based on user identities, e.g. John has R.W. access to HR files.
R and W are read and write. HR, I don't know what is it. And Mary has read and write to sales. Okay, so you see, they have different read and access. They have different access rights for different subjects. Okay.
Mandatory AC, MAC. AC policy based on security labels, e.g. secret clearance needed for access.
Okay, yes, secret clearance. We usually see that on movies. It is the same.
DAC, discretionary access control. Access authorization is specified and enforced based on the identity of the user. DAC is typically implemented with ACL, access control lists.
Yes, this is usually what we do. We specify specific access controls to specific user groups such as admin user or lecturer or student or guest and such. You usually see that on forums if you are using that, moderators, section moderators, global moderators, administrators and such.
DAC is discretionary in the sense that the owner of the resource can decide at his/her discretion who is authorized. Operating systems using DAC, Windows and Linux.
Okay.
DAC principles. AC matrix, general list of authorizations, impractical, too many empty cells.
Okay, so if we use access control matrix for each object, you see, it is impractical because too many empty cells there are. For example, subject names. Okay, let's fix this from the slides. Okay, so the subject names are being the users. You see, each user has specific rights to each object. Object 1, read and write. Object 2, nothing. Object 3, X. Object 4, read and such. And I will update the PowerPoint and publish it as PDF file. Okay, DAC principles. Okay, and there is also
Access control lists, ACL.
okay.
Associated with an object, represent columns from AC matrix, tells who can access the object.
So this is a rather different representation. In this case, you hold lists, and the lists hold access rights for each user for each object. Okay.
ACL in Unix. Each file and directory has an associated ACL. 3 access operations, read, from a file write, to a file execute, a file.
So X is execute.
Access applied to a directory, read, list contents of dir write, create or rename files in dir execute, search directory.
dir is directory.
Permission bits are grouped in 3 triples that define read, write, and execute access for owner, group, and others. A indicates that the specific access right is not granted. RWRR means, read and write access for the owner, read access for group, and for others, world.
So read and write for owner and no permission to execute. And this is read access for group, and this is read for the rest. Okay.
RWX means, read, write, and execute access for the owner, no rights for group and no rights for others.
Okay, and for example, I can show you what does this mean in Windows terms. When I click properties and click security, you see it shows me that my account have full control, modify, read and execute, read, write, and special permissions, and administrator same, and the system is same. When I click advanced, more options appears. You see there is auditing, effective access, permissions, and I can click view, show advanced permissions. Okay, full control, traverse folder, list folder, read attributes, read extended attributes, create files. You see, each of these are different permissions, and each account composed on Windows can have different access permissions. There is also, I will show you something else. You can change directory permission as well. From here, let's click edit, and from here, can I remove it? No. Can I remove it? Is no. Okay, I can say deny. Okay, when I say deny, let's see what happens. Oh, since I am both administrator and Furkan Gözükar account, it wouldn't work anyway. So you get the idea of permissions.
Capabilities. Focus on the subjects. Access rights stored with subjects represents rows of AC matrix. Must be impossible for users to create fake capabilities. Subjects may grant own capabilities to other subjects. Subjects may grant the right to grant rights. Challenges. How to check who may access a specific object, how to revoke a capability. Similar to SAML security token. MAC, mandatory access control. Access authorization is specified and enforced with security labels, security clearance for subjects, classification levels for objects. MAC compares subject and object labels. MAC is mandatory in the sense that users do not control access to the resources they create. A system-wide set of AC policy rules for subjects and objects determine modes of access. OS with MAC. SE Linux supports MAC. MAC principles, labels. Security labels can be assigned to subjects and objects, can be strictly ordered. Security levels, e.g., confidential or secret, can also be partially ordered categories, e.g., sales dep, HR dep. Dominance relationship between labels LALB means that label LA dominates label LB. Object labels are assigned according to sensitivity. Subject labels are determined by security clearance. Access control decisions are made by comparing the subject label with the object label according to specific model. MAC is typically based on Bell-LaPadula model. See later.
So subject, compare object, okay.
Bell-LaPadula, the classical MAC model. SS property, simple security, no read-up. A subject should not be able to read files with a higher label than its own label, because otherwise it could cause unauthorized disclosure of sensitive information, so you should only be able to read documents with an equal or lower label as your security clearance level. Asterisk property, star property, no write down. Subjects working on information, tasks at a given level should not be allowed to write to a lower level, because otherwise it could create unauthorized information flow. So you should only be able write to files with an equal or higher label as your security clearance level. Bell-LaPadula, MAC model, SS property, no read up.
Okay, so current subject label is secret. Therefore, we can read secret and confidential objects. However, we cannot read top secret because it is higher level than our secret level, and current subject label is secret. Therefore, we cannot write to confidential objects. However, we can write to secret and top secret objects. Okay.
Labels in Bell LaPadula. Users have a clearance level LSM, subject max level. Users log on with a current clearance level LSC, subject current level, where LSC LSM objects have a sensitivity level low. Object SS property allows read access when LSC low. Asterisk property allows write access when LSC low.
Okay, so the relationships are shown like this. Subject max level clearance, write access, subject current label here, and possible read access. Okay, so the dominance comes from top to bottom. Okay, there is also Wikipedia. Okay, anyway, if you wonder more, if you wonder more information, you can check it out.
Combined Mac and DAC. Combining access control approaches, a combination of mandatory and discretionary access control approaches is often used. MAC is applied first, DAC applied second after positive MAC, access granted only if both MAC and DAC positive. Combined MAC, DAC ensures that no owner can make sensitive information available to unauthorized users, and need to know can be applied to limit access that would otherwise be granted under mandatory rules. RBAC, Role-Based Access Control. A user has access to an object based on the assigned role. Roles are defined based on job functions. Permissions are defined based on job authority and responsibilities within a job function. Operations on an object are invocated based on the permissions. The object is concerned with the user's role and not the user.
Okay, so there is user role 1. You see, you can assign multiple roles to a user, and each role has different permissions to different files. User change frequently, roles don't. Okay. Debug can be configured to do Mac and or DEC.
RBAC Privilege Principles. Roles are engineered based on the principle of least privilege. A role contains the minimum amount of permissions to instantiate an object. A user is assigned to a role that allows her to perform only what's required for that role. All users with the same role have the same permissions.
Actually, the Windows uses this as well. You see, there is administrative role, user role, and guest role, such as that.
ABAC and XACML. ABAC equals Attribute-Based Access Control. ABAC specifies access authorizations and approves access through policies combined with attributes. The policy rules can apply to any type of attributes, user attributes, resource attribute, context attributed, etc. XACML used to express ABAC attributes and policies. XACML equals Extensible Access Control Markup Language. The XACML standard defines a language for expressing access control attributes and policies implemented in XML, and a processing model describing how to evaluate access requests according to the rules defined in policies. XACML attributes are typically structured in ontologies. Attribute-based access control. ABAC makes AC decisions based on Boolean conditions on attribute values. Subject, object, context, and action consist of attributes. Subject attributes could be name, sex, job, role, etc. Each attributes has a value, e.g., name subject equals Alice, sex subject equals F, role subject equals HR staff, access type action equals read, write, owner object equals HR, type object equals salary. The AC logic analyzes all attribute equals value tuples that are required by the relevant policy. E.g. permit if role subject equals HR staff and access type action equals read and owner object equals HR and time query equals office hours.
Okay, so the ABAC model is AC policies, meta policy, policy 1, 2, 3, context conditions, and access action request by the subject. ABCA functions, AC decision logic, AC enforcement. So it checks subject attributes, name, affiliation, clearance, etc. Object attributes, type, owner, classification, etc. And if they are matching, access to object.
Global consistence.
Okay.
ABAC systems require an XML terminology to express all possible attributes, and their values must be consistent across the entire domain, e.g. the attribute role and all its possible values, e.g. role subject equals HR staff, must be known and interpreted by all systems in the AC security domain. Requires standardization, e.g. for access to medical journals, medical terms must be interpreted in a consistent way by all systems. Current international work on XML of medical terms, consistent interpretation of attributes and values is a major challenge for implementing ABAC. ABAC, plus, and on the positive side, ABAC is much more flexible than DAC, MAC or RBAC. DAC, MAC and RBAC can be implemented with ABAC, can use any type of access policies combined with an unlimited number of attributes, suitable for access control in distributed environments, e.g. national e-health networks. On the negative side, requires defining business concepts in terms of XML and ontologies, which is much more complex than what is required in traditional DAC, MAC or RBAC systems. Political alignment and legal agreements required for ABAC in distributed environments. Meta policies I.C.O. Inconsistent policies. Subdomain authorities define their own policies. Potential for conflicting policies, e.g. two policies dictate different access decisions. Meta policy rules needed in case the ABAC logic detects policy rules that lead to opposite decisions. Meta policy takes priority over all other policies, e.g. meta policy deny overrides. If one policy denies access, but another policy approves access, then access is denied. This is a conservative meta policy. Meta policy approve overrides. If one policy denies access, but another policy approves access, then access is approved. This is a lenient meta policy.
Okay, so I want to check something. Mm,
If a Windows object does not have a discretionary access control list (DACL), the system allows everyone full access to it. If an object has a DACL, the system allows only the access that is explicitly allowed by the access control entries (ACEs) in the DACL. If there are no ACEs in the DACL, the system does not allow access to anyone. Similarly, if a DACL has ACEs that allow access to a limited set of users or groups, the system implicitly denies access to all trustees not included in the ACEs.
Okay, so you see Windows uses this creationary access control list and access control entries.
In most cases, you can control access to an object by using access allowed ACEs. You do not need to explicitly deny access to an object. The exception is when an ACE allows access to a group and you want to deny access to a member of the group. To do this, place an access denied ACE for the user in the DACL ahead of the access allowed ACE for the group. Note that the order of the ACEs is important because the system reads the ACEs in sequence until access is granted or denied. The user's access denied ACE must appear first, otherwise, when the system reads the group's access allowed ACE, it will grant access to the restricted user. The following illustration shows a DACL that denies access to one user and grants access to two groups. The members of Group A get read, write, and execute access rights by accumulating the rights allowed to Group A and rights allowed to everyone. The exception is Andrew, who is denied access by the access denied ACE in spite of being a member of the everyone group.
Okay, so you see this is how Win32 authorization works. By the way, I don't know if this applies to recent Windows. Win32 API. Yeah, probably still applies to newest Windows versions as well. Win32 API. Yes. Okay. So you see, this is how it is used in real life application and in Windows. You get the idea. I will make an addition to your final project, which is related to course attendance. Now I will show you that rule. Okay. So the new rule is about your comments that you have been making or you should have been making to our videos. Okay, so everyone will be sending a Word or PDF document along with their final project files. This document will contain screenshots of your all comments to the lecture videos, all of the 14 lecture videos. If there are more, you of course all of them. But I am supposing that there will be 14. Take screenshots with high resolution. Your comment has to be clearly readable. Those who fail to send the document will be counted as not attended to the lectures, therefore they will get FF. Okay. So this is the new rule I have decided. This is not an extra rule actually. You should already have been making comments, therefore this is nothing new. But be aware of that. Okay. Okay, let's close this and this. Okay, let's upload to our GitHub repository. Okay, it is updated. So it is sufficient for this week. Hopefully see you next week. Please try to be careful with the coronavirus and hopefully see you.